Hi everybody, today's video is all about graphing quadratic functions. So the parent function that we always start with is y equals x squared. Anytime it has an x squared, that means it's quadratic. So how we can figure out where this graph goes is maybe we would make an xy table. Well, if I start maybe with -1, 0, and 1, well, -1 squared is +1, and 0 squared is 0, and 1 squared is 1. So now I have 3 points. I can start with my graph. If I wanted to, I could choose 2 and -2. Those squared are 4. But the graph of y equals x squared is called a parabola. Hopefully you remember some of this from um, your past math experiences, but I know that you all know how to make an xy table, so you can always do that to graph a function. So the first thing we're going to do is graph something in vertex form, which would mean y equals a times x minus h squared plus k, where our vertex is hk, and we can figure out the shape by a and whether it opens up or down, and I'll show you how that's going to work. So for number 1, we have x squared minus 9. Well, that really means 1 times x minus 0 squared plus 9. But we didn't write the 1 in front or the minus 0 because we already know. But since the 1 is positive, this graph opens up. Also, since it's a 1, the shape is standard. Now, the vertex here, whatever's inside the parentheses next to my x, is the x part of my vertex. And the outside is my y portion. So it's 0, 9 as my vertex. So I know that I'm going to start at, and you know what? It is -9. So my vertex is 0, -9. And I'm going to plot that point. So my line of symmetry has always something to do with my vertex. In this case, it is x equals 0. It's always the vertical line going through your vertex. So since this is a 0 in my vertex, it's a 0 in my equation. So the next step is to find the x-intercepts. Well, there are definitely more than one way to do that, but to find your x-intercepts, you need to set equation equal to 0, right? We need to figure out what x values we get when our equation is equal to 0. And then we can also solve a couple of different ways. You can factor or you can use square roots. I'm going to add 9 to both sides. So I have x squared equals 9. And then to get rid of that square root, I've got x equals plus or minus 3. So that means my x-intercepts are 3, 0 and -3, 0. Because an x-intercept is on the x-axis, and my y value is always equal to 0 there. So you can algebraically find your x-intercepts. And then you have 3 points. That was kind of bad. Let me redraw. And that's really what you need to draw the graph of a quadratic equation. All right, let's move to number 2. So in front, I see a -2. So I see that it opens down. And this 2 also tells me something, that my graph will be narrow because 2 is bigger than 1. Now, you'll see, which is always true, if the number in front, a, well, the absolute value equals 1, it's going to be standard. If it's less than 1, it's wide. If it's greater than 1, it's narrow. And since 2 is greater than 1, it is narrow. And we can all agree at the end, I'm sure, when we see the graph that it's narrow. So the vertex here, whatever's inside is the x portion, and it's always opposite. So since this says +3, my x term is -3. That's only true for the x. And then the y is -2. So I'm going to go -3, -2. which means my line of symmetry is x equals -3. And I'm going to draw that dashed line through my vertex. And it's a vertical line, so it's x equals -3. So we can maybe algebraically find the x-intercepts just like we did in example 1. But in this case, I want to look at the calculator. So if you go to y equals and type in the equation, we can check out that graph. And I want you to start with zoom 6 so we can get back to that standard window. And are you thinking what I'm thinking? That, wow, Miss Nardini, this graph does not cross the x-axis. And you're right, it doesn't. And that's okay. Sometimes there are no x-intercepts. So we're going to have to do some other work to find out other points. So we can make an xy table. Our vertex is -3, -2. And we really need 3 points. So I like to choose one smaller and one bigger than the x value in our vertex. Now you can plug in -4 up here. You could say -2 times -4 plus 3 squared minus 2. And you could get that value for y. But I'm going to show you how to do it in your calculator because I know you guys are getting really good at those XY tables. So you only have to do this one time, but let's just make sure our tables are good. Your table could really start anywhere. Maybe yours says 0, and you want it to go up by 1s, and those should both be autos. Once you do this, you really shouldn't have to do it again unless there's a problem that requires you to do so. So if you go to second table, mine's is starting at 0, but the x values I'm curious about are negative, so I'm just going to use the up arrows to find them. So if I look at -4, my y value is -4. If I look at -2, my y value is also -4. So I'm going to fill in my table. So that's another option, algebraically or on your calculator. So -4, -4, and -2, -4 give me enough information to draw my graph. All right. Well, sometimes your equation is not in vertex form, so what do you do? There are two options. Option A, rewrite the equation into vertex form using completing the square method and follow the steps from above. An easier way, in my opinion, but you can decide, is part B to find the vertex, maximum or minimum, and the zeros on your calculator. And then you can watch this video right here if you need any extra help. Otherwise, you can always rewatch what I'm doing in this video right now. So graphing in factored form, that means I have an equation that's already been factored. And it looks like this, where Q and P are the x-intercepts. So in this one, in front I have a 1, so it opens up because it's positive, and it's a 1, so it's standard. I don't know the vertex or the line of symmetry, but when it's in factored form, I know that if I set this equal to 0, I could say, oh, x minus 1 equals 0, or x plus 2 equals 0. So x equals 1, or x equals -2 are my zeros, which are also my x-intercepts. So if you want to write that down, we normally refer to those x-intercepts as zeros because y is equal to 0. That's when the function is equal to 0. So I've got 1, 0 and -2, 0, just based on the equation. So 1, 0 and -2, 0. And then to find the vertex, I need to either find the max or the minimum, just depending on what your graph looks like. So let's go to our calculator and try this. So I've got x minus 1 and x plus 2, and I'm going to go to my graph. So we can all probably agree that the vertex is right here where you can see my yellow circle, and this is where my graph comes to a minimum. It's at the bottom, so I have to calculate the minimum. So second calc, where all the fancy calculating stuff are, we're going to go down to minimum. We want to make sure that our cursor is as close to the 0 or that minimum as possible. So in my case, I am going to need to move to the left a couple times. Go slow just in case you lose it again. And I'm going to put my cursor right as close to my vertex as possible. And your calculator is giving you directions. It says, all right, first I need a left bound. Basically, I need you to tell me where to cut off my calculations to the left and then to the right. It's just providing a range for your calculator. Anyway, so when it says left bound, you're going to hit the left arrow maybe 2 or 3 times and press enter. And then you're going to go back to the vertex because now your calculator wants a right bound. So you could hit your right arrow key maybe 2, 3 times and then press enter. And then it says to guess, but we don't really need to, so we're going to press enter. And here, our minimum is at negative 0.49999. Well, sometimes it looks weird, but that's really like negative 0.5, and y is negative 2.25. So my vertex is negative 0.5 and negative 2.25. If you're not sure you were getting an error when you were calculating that, I want you to try again, please. Rewatch, rewind, do it again. So negative 0.5 and negative 2.25. So that means my line of symmetry is x equals negative 0.5. So I can draw my line of symmetry and draw my graph. So that's how you do it when you have factored form. When we have standard form, we do something pretty similar. In this case, the number in front is negative, so that means it's going to open down. And 1/2 is less than 1, so that means our graph is wide. So we have to do something similar here. We don't know any of this information based on our equation. Now we can algebraically find it, right? We could complete the square and get that information, or we can turn to our calculators. So let's do that. I've got negative 1/2 x squared minus 6, or no, minus x plus 6. And I'm going to go to my graph. So the first thing I need to do is find my vertex. So I want you to write down all the information that you need to make sure you can do this in class. So in this case, since my graph is opening down, my vertex is at the maximum. So second calc maximum. And I'm going to put my cursor so it's blinking right on my vertex or close to it. I need a left bound. So I'm going to go to the left maybe 3 times, press enter. I'm going to go back to my vertex. I'm going to hit for the right bound to the right 3 times, press enter, enter one more time. Here, my maximum is negative 1, we'll round that to negative 1, and 6.5. So negative 1, comma 6.5. So that's about right here. So my line of symmetry is going to go through that point. So x equals negative 1. So again, here we need to find our x intercepts. This could be the confusing part, so make sure you pay attention. We're looking for zeros. So second calc, going to 0. We need to put our cursor on top of our zeros. Well, my first one is, I'm going to do the one to the left first. You could start with either. It doesn't really matter. But I want you to put your cursor as close to the 0 as you can. Again, it needs a left bound. So I'm going to hit my left arrow 2, 3 times and press enter and go right back to my 0. Now I need a right bound. So I'm going to hit my right arrow key to the right a couple times, press enter and enter one more time. So I've got negative 4.6 and 0. And then we can find the other. So to find the other, I'm going to go second calc, number 2 to 0. I'm going to put my cursor again on my other 0 this time. And once you get there, left bound, so go to the left, press enter, go right back to the 0, then right bound, go to the right, press enter, and press enter one more time, and at 2.6 comma 0. So negative 4.6 and 2.6 gives us the information we need to graph that equation. So I would like you to either watch the video for extra practice, or rewatch these as many times as you need until you feel confident to do this on your own. We'll do the last few problems in class together. See you then.